So now that we're familiar with how to use explicit definitions to find a term we want in a sequence, we're going to focus on how to write them. So what we're asked to do here is to write an explicit definition for this sequence. And we could do this recursively because that's something we've done in the past. Right? We could say that the first term clearly is 13, and there's a pattern here that looks like it's plus 8. So I could say that to find the nth term, I just take the previous term and add 8. This would be recursive. But we're starting to learn that these aren't going to be very useful ways to define functions, because if I need to find the 11th or even, the 10th term, it's going to take a lot of work to get there. So what we want to do is have a way to define this explicitly so that we can just plug in the value of whatever term we want. So the first thing I'm going to do, and I want to get in the habit of doing this, is checking to see what type of sequence this is. If it's arithmetic, then I can do term 2 minus term 1. So remember, these are terms 1, 2, and 3 here. If it's arithmetic, then I can do the second term minus the first term, and that should give me the exact same thing as the third term minus the second term. And so in this case, that's 21 minus 13, and 29 minus 21. And since those are both 8, I will say, therefore, it's arithmetic, and the common difference is 8. So what I'm going to give you now is the general form for all of these explicit definitions if they are arithmetic. So you can write all arithmetic sequences of the form a of 1 plus the common difference times n minus 1, and that will give you an explicit definition for that arithmetic sequence. So in this case, I'm going to write a of n equals, my first term is 13, something we already identified, plus d, which in this case is 8, we said the common difference is 8, times n minus 1. Now I could use that to find any term I want here. If I wanted to find the 15th term, I just plug in a 15 for n. And so that would be 13 plus 8 times 14. 125. So if I did want that 15th term, that's pretty easy to do now. And I could double check and make sure that this works by testing to make sure that by plugging in a 1, I get 13, and by plugging in a 2, I get 21, and so on. So you could check this, but this will work for every arithmetic sequence. So this is a formula that we probably want to have boxed, circled, memorized somewhere. So let's practice using that a couple times. Define the sequences below explicitly and use that definition to find the 12th term. So first what we're going to do is check to see if these are arithmetic. So when I do -2 minus -12, do I get the same thing as when I do 8 minus -2? Don't forget to do keep, change here. This is 10 equals 10, so therefore it's arithmetic, and the common difference is 10. So I'm going to set this up just like I did the previous example. I need the first term, which is -12, plus the common difference, which is 10, times n minus 1. And so that is my explicit definition. Now if I want to find the 12th term, all I have to do is plug in a 12 to this. Which is going to be -12 plus 10 times 11. So the 12th term is 98. So this is our explicit definition, and this is the 12th term. And that was pretty easy to do once we had that explicit definition. In the next sequence, I am again going to try to prove that this is arithmetic. So I have to do 50 minus 100 and see if that's the same thing as 0 minus 50. This is just showing that I do have a common difference here. 50 minus 100 is -50, and 0 minus 50 is also -50, so it's arithmetic. And the common difference is -50. So when I write my explicit definition, I'm going to follow that same formula. I need the first term of the sequence, which was 100, plus the common difference, which was -50. And what you probably want to do here is just write that as -50 but it doesn't really matter, times n minus 1. And now I'm asked to find the 12th term, so c sub 12 equals 100 minus 50 times 12 minus 1. 100 minus 50 times 11, negative 450. So that would be the 12th term, and the explicit definition is right there. Let's do a couple more examples. Find the specified term of each sequence. Okay, so we're given the sequence and we're asked to find, in example 1, f of 10. So the first thing I'm going to do is prove that it's arithmetic, and I'll do negative 1 minus 1/2 and see if that's the same as 2 minus negative 1. Negative 1 minus 1/2 is 3 halves, negative 3 halves. And 2 minus negative 1 is 3. These are not the same. So what I've shown is that it's not arithmetic. So let's try to figure out then if maybe it's geometric. So to see if it's geometric, because arithmetic didn't work, we're going to use division instead. So I'll do negative 1 divided by 1/2 and see if that's the same as 2 divided by negative 1. So it's the same order as if we were testing for arithmetic, but we're dividing instead of subtracting. So over here, I'm going to rewrite this. That's negative 1 times the reciprocal, and the reciprocal of 1/2 is just 2. So this is actually going to equal negative 2 on this side, and 2 divided by negative 1 is also negative 2. So therefore, it's geometric, and instead of saying that we have a common difference, we're going to say we have a common ratio of negative 2. So now we need a way to define geometric sequences explicitly. So let me give you your general form for an explicitly defined geometric sequence. So just like we had a definition for arithmetic sequences, we have one for geometric sequences. The pieces here are still, you have your first term. R represents the common ratio, which we just found to be negative 2, and it's all raised to the n minus 1 power, so that n minus 1 is the exponent. So if I apply that here, then I'm going to call this f of n. The first term was 1/2. The common ratio was negative 2, and the exponent is n minus 1. So now I can use that to find the 10th term. 1/2 times negative 2 to the 10 minus 1, which is 1/2 times negative 2 to the 9th. So this will be 1/2 times negative 512, or negative 256. So the 10th term in that sequence would be negative 256, which is pretty easy to find once you have that explicit definition. The last one for today, let's test and just see if it's arithmetic first. So I'm going to do 729 minus 2,187 and see if that's the same thing as 243 minus 729. These are not the same, so it's not arithmetic. So let's see if it's geometric. We'll do the same thing with division. 729 divided by 2,187, and see if that's the same thing as 243 divided by 729. If I reduce these fractions, I'll get 1/3 and 1/3. So therefore it is geometric, and the common ratio is 1/3. All right, so let's set this thing up as an explicitly defined sequence. G sub n equals, our first term is 2,187. Just following this formula here. Our common ratio is 1/3, and that's raised to the n minus 1 power. So that is an explicit definition for this sequence, and now we're asked to find the 8th term. So all I have to do is get a calculator, and what you guys should probably be using is Desmos to do all of this because you don't have the graphing calculators. 8 minus 1 is going to end up being 2,187 times 1/3 to the 7th power. So as it turns out, the 8th term in the sequence is 1. All right, so tomorrow you're going to have some practice related to this, and then on Friday our quizzes are going to be related to explicit definitions, but this is obviously much more challenging than just using an explicit definition. Now you're writing them and then using them.